Okay, so we're going to be starting our notes over stoichiometry, which to do this, you're going to write down, pause the video whenever you need to, write down what you see on the screen. I will tell you that if something is typed in red, like the little example problem right there, that's not intended for you to copy down. That's just for us to talk about. So that's what the red is about. So stoichiometry is basically using chemical amounts, using a periodic table and a balanced equation to predict how much product we're going to make from a reaction. It's a little bit more complicated than that, but that's pretty much the gist of it. So we're going to treat every balanced equation like a recipe where you have sugar and flour and vanilla or whatever, and you put it together and you make this many cookies. So it's just a little bit more specific and a little bit more strict in terms of the amounts that you use, because when molecules react with each other, they have to react in very precise amounts. So if you look at our example question there, how many grams of water would you need to decompose 45 grams of oxygen? What we know looking at this balanced equation is that for every 2 water molecules that decompose or break down, we will get 2 hydrogen molecules and 1 oxygen molecule. That ratio is very important. It's also the ratio, if I were to bump those numbers up, and let's say instead of individual water molecules and hydrogens and oxygens, let's say I wanted to talk about them by the dozen, right? So in other words, 2 dozen water molecules would break down and give me 2 dozen hydrogen molecules and 1 dozen oxygen. All I'm doing is basically multiplying each number by 12, because a dozen always equals 12. Well, you might know what I'm getting at here. If you remember first semester, we talked about chemical quantities called the mole. The mole just means a whole lot. It's a huge counting number. If a dozen equals 12, a mole equals 6.02 times 10 to the 23rd. Now, we're not going to be specifically using that number, Avogadro's number, but we are going to be using the mole concept, because 2 moles of water molecules would break down to give you 2 moles of hydrogen and 1 mole of oxygen. So that's a very important thing to remember. That's what stoichiometry is based on, is those molar relationships. So if I go down to the same equation, but this time I'm asking you a little bit different question. And again, you want to write down the question. You also, by the way, want to have a calculator handy, and eventually you'll need a periodic table. So if you don't have those handy, you might want to grab those now. But go ahead and pause and write down the question, or at least the first question. Okay, so this is going to be a unit conversion. And like any unit conversion, we are going to start by writing down the thing that I'm given. In this case, 4.0 moles of oxygen. And oxygen, of course, refers to O2. And I like to write it as a fraction. You don't really have to, because anything can be written as a fraction by putting it over 1. But I like to do that because then I'm multiplying. I've got just a bunch of fractions I'm multiplying. So if you remember from unit conversions, the unit we're trying to get rid of has got to go on the bottom, in the denominator of the second fraction. So right now, I've got moles of O2. So moles of O2 would have to go on the bottom. So just like if I were converting centimeters to meters. If I'm starting with centimeters, if I'm starting with 140 centimeters, and I want to convert that to meters, well, I would put centimeters on the bottom and meters on the top. And I would use the fact that 1 meter equals 100 centimeters, and I would do the division, so I'd get 1.4 meters. This is the same concept, only this ratio, this 1 to 100 ratio, is going to come from a different place. It's not going to be one that we just memorize. It's going to come from the balanced equation. So let's go back to my problem up here in green. I'm going from moles of oxygen to moles of water, which means moles of water has to go on the top. And the relationship between these two, if you were paying attention just a minute ago, I said the balanced equation actually gives us the relationship between moles of 2 substances in the reaction. So 2 moles of water would break down to give us 1 mole of oxygen. It would also give us 2 moles of hydrogen, but this question isn't really concerned with that. So I'm going to put the 2 in front of water, just like it was in the balanced equation. And I'm going to put a 1 next to oxygen, which there's no 1 written there, but it's implied. And so I get 4 times 2, which is 8. And just to keep my sig figs, it's going to be 8.0 moles of H2O. Okay. Let's try another one. So 0.76 moles of hydrogen this time. So 0.76 moles of hydrogen is going to go over 1. Go ahead and see if you can figure out what's going to go on the bottom of the next fraction. Okay, so we're trying to get rid of moles of H2, so that's going to go on the bottom. And then what would go on top? So moles of water is what we're being asked for, so that's going to go on top. And I get that ratio from the balanced equation, right? So moles of H2O, there's 2. Moles of H2 is also a 2, which means 0.76 times 2 divided by 2, which is still just 0.76. And that's my answer. This one's a little different because it involves grams, but it's going to start out the same way. So 1.5 moles of H2O. So again, we're going to try to get rid of moles of H2O. Now this problem is different because it's asking us for grams of oxygen. Okay, I'd like to be able to put grams of oxygen on top, but I can't really do that because there's no relationship between grams of oxygen and moles of water because they're 2 different substances. So instead, I'm going to use moles of oxygen as a stepping stone. Because once I get moles of oxygen, I can then convert that to grams of oxygen. And I'll talk about that in a second. But moles of O2, or sorry, moles of H2O to moles of O2, again, comes from the balanced equation. So there is an implied 1 in front of O2, and there is a 2 in front of H2O. Now, this is not the unit that we want for our final answer. That's moles of oxygen. I'm being asked for grams of oxygen. But if you grabbed a periodic table, you should be able to tell me the relationship between moles of oxygen, or anything on the periodic table, and grams. So if I go to the periodic table, I'm going to see a number next to oxygen. It's like 15.999 or something like that, but it rounds to about 16.00 grams, and that is per 1 mole of that substance. Now, because it's O2, I have to take that 16.00 and multiply it by 2, right? So it's going to be 1 mole of O2 equals 16 times 2, or 32 grams of oxygen, and I've got my problem all set up. So now we just have to do the math. And go ahead and do the calculation. Okay, so you should have gotten 24. And 2 sig figs is correct for that, so I'm just going to leave it at 24. And our unit for that would be grams of O2. So you just did a mole to gram conversion. We went from moles of one thing, we'll just call it A, in this case it was water, to moles of a different thing, so that was this step. In this case, it was moles of oxygen, but I'm just going to call it moles of B, meaning a different substance. And then we took it to grams, from moles to grams of that second substance. So grams of B. Now, the last question that we'll have to answer is how do we go from, if we start with grams of A, how do we go all the way to grams of B? So here's an example like that. I'll have to recopy my equation. It's the same equation. So H2O goes to H2 plus O2, and a 2 in front of water, and a 2 in front of hydrogen. So same equation. You don't have to recopy it. It's already in your notes. But the question this time is asking us for grams of water, and it's giving us grams of oxygen. So here we're going all the way from grams of one substance, we'll call it A, all the way to grams of B. In between, we're going to have to go to moles. So this is going to be the longest problem that you can possibly do because you're going from one end all the way to the other. Moles to moles is the shortest, then moles to grams. The longest would be grams to grams. So if I have 45 grams of oxygen, and I want to get rid of grams of oxygen, I'm going to put that on the bottom. Now again, I want to go to grams of water, but I can't go directly from grams of one thing to grams of another. So what do you think the stepping stone for this problem is going to be? What do you think? What unit do you think is going to go on the top? Okay, so it's going to be moles of O2. Okay. So because if I go to the periodic table, I do know the relationship between grams and moles. And I just used it in the last problem. 1 mole of O2 to 32 grams of oxygen. We just used this one up above. The only difference is we had the 32 over 1 up above because it was grams over moles. Here we have moles over grams, so the 32 is on the bottom. It's got to go next to the number from the periodic table. Or, I'm sorry, the number from the periodic table has to go next to grams. Okay, so then that gets rid of grams of O2, and then from moles of O2, where do you think I have to go next? Okay, so the next step is going to be to go to moles of water. I can't go directly to grams of water. I have to go to moles first because we can't convert between grams of one thing and moles of something else. So this ratio is going to be 2 to 1, and again that comes from the balanced equation. That cancels moles of oxygen. And then we have one more step because the question is asking me for grams of water, not moles of water. So we do have one more step, and that is to go from moles of H2O to grams. And again, anytime I see grams, I know I'm going to the periodic table for that. And so I just have to add up. Each hydrogen is 1.01, so that times 2 plus 16 for oxygen. So 1.01 times 2 is 2.02, plus 16 would be 18.02. And so go ahead and do the math. 45, just basically multiply by the top, multiply everything on the bottom, and then divide top by bottom. So 45 times 2 times 18.02 divided by 32, and see what you get. Okay, so I got 50.68. That's a little bit too many sig figs because my starting number 45.0 only has 3. So I'm going to say or 50.7, and then my unit would be grams of H2O. Okay, so there it is. That's about as long a stoichiometry problem as we can do. We went all the way from grams of A to grams of B. We always use the periodic table when we've got grams involved, and we always use the balanced equation when we're going between moles and moles of two different substances. So rewatch this as much as you need to, and come in with questions, and we'll see you next time.